Hello and welcome to this discussion where we are going to discuss about Java GC monitoring. So let's get it started now. So what we are going to discuss is introduction to GC monitoring, type of problems which can be addressed using Java garbage collection monitoring, different areas of heap, how JVM heap works. And then we'll just have a brief summary of different GC tools, and then we're going to do a demo of Java GC monitoring using one of the tool. So let's get started. So what is GC monitoring? Just give me a sec. Okay. So garbage collection is one of the most attractive feature of Java, where developers do not need to explicitly manage the memory or heap. So in other languages like C, C++, etc., you have to do alloc, malloc, and all those kind of things. Then after you are done, you have to clear the memory. So in Java, GC is automated. So whenever there is a requirement of extra heap or something, JVM will automatically trigger the GC, or it can trigger internally for other purposes for cleanup etc. also. So Java will automatically handle garbage for you. But having said that, there are certain best practices which you should follow. For example, releasing the freeing the objects which are no longer in use so that reference is cleared and Java GC can reclaim it. Java JVM will determine when heap is under pressure and will automatically try to reclaim free spaces, which is called garbage collection. All platforms, runtimes, etc. need to manage memory allocation and deallocation properly, whether it's Java, C, C++, or for that matter any operating system, they need to manage the memory allocation. So GC monitoring refers to the process of figuring out how JVM is running GC. For example, we can find out when an object is young, has moved to old, and how much. We'll see what does this mean in following slides. Or when stop the world has occurred for how long. So when GC happens in Java, so there are different garbage collection algorithms available in Java. So there are some which can really freeze your application. Whatever application is doing, it will simply pause it, run the GC, and then resume the application. So there may be scenarios where the stop the world kind of thing is happening. Your application has suddenly stopped, your JVM freezes. So that kind of scenario means your garbage collection is not properly tuned. So you need to do the monitoring and analysis of your garbage collection logs and see how you can tune it. So type of problems which can be addressed using GC monitoring. GC monitoring is carried out to see if JVM is running garbage collection properly or not, and to check if additional GC tuning is necessary. So if you look at your GC logs, do the proper GC monitoring, you can find out whether any tuning is required as far as garbage collection is concerned or not. And then for example, you can tune your heap sizes or kind of GC algorithms which is being used. You can change those depending upon the monitoring you have done, or you can resize your heap, your different heaps, different areas in the heaps. All those things can be, you can conclude that based on your GC analysis only. Badly tuned heap and GC can introduce performance issues like pause time, high response times, application freezes, CPU spikes, etc. So if you're encountering these kind of situations in your application, for example, suddenly your application freezes and response times goes high without any clear cut reason why it is happening, so garbage collection can be one of the reason for that, and GC monitoring and GC analysis can be one of the activity you need to carry out. You may need to carry out other things like threat analysis etc, but GC can be very big factor in situations like this. So that's why you need to have a look at your GC and its configurations also. We will not go in details about different GC algorithms which are available or how JVM heap works. That's a separate discussion, so we'll not go on total deep dive into this, but we'll definitely have a look at how JVM heap works in a very at a very high level. So how JVM works or different areas of the heap. So at high level, your JVM heap is divided into these kind of structure. So one area in JVM heap is called metaspace. In earlier versions of Java, I think till Java 7, it was called permanent space. Now it is called metaspace. Metadata related to JVM, etc. That all, whatever JVM, whatever metadata JVM needs to function properly, that is stored in the metaspace of the heap. Then there is hidden. So whenever you create a new object or your application starts, all objects starts from hidden area in the heap. So this area, the, whenever it is about to get filled or new memory is required, minor garbage collections happens, which are optimized garbage collections. And when the garbage collection happens, whatever garbage, whatever objects survives the garbage collection, they are moved to survivor space S0 or S1. So you allocate a object, it will be allocated here in the hidden space. And when GC is here is very fast. It is called minor GCs, managed garbage collection. And if a object survives, it will move to survivor space, either S0 or S1. Okay, so what are S0 and S1? These are called survivor space. One is designated as empty and other as live, alternating with every GC cycle. So you allocated an object here, few say two objects allocated. One survives the garbage collection and it will be moved to uh, survivor space, say S0. And when this is about to be filled, when GC happens, so what will happen, S0 will be freed, all the objects whichever were here, they will be moved to S1 and S0 will be marked as free, and next GC reverse will happen. So S0 and S1, they are only one is used in most of the scenario. There may be scenarios where both have to be used, but that is a kind of memory leak problem. When you have a serious memory leak issue, then only it is very rare that you will encounter those kind of scenarios, but it may happen. But generally only one of the survivor space will be used. So, and then the old memory space or a whole old generation heap. So this subspace holds older objects with longer lifetimes. When this space is filled up, GC will garbage collection will do a full garbage collection, and which cost more in terms of performance. So you allocated object initially. When you allocated object initially, it will go to the hidden. Over time it will move to S0 or S1 recursively, not recursively, but alternatively. Sorry, give me a second. Uh, so now sorry. And then after some time, when your object passes, it escapes few garbage collections, it will move to the old. So any object which is which your application requires for longer times, after certain GCs, because it is still being refreshed, it will automatically move to the JVM old heap. And when this old space is about to be get exhausted, full garbage collection will run. But full garbage collection is performance intensive, and you may see your degradation in the performance when the full GC happens. So now there are some of summary of different GC tools, so we'll have a look at that. So for example, JDK comes up with JVisualVM, JStat, GCVS, etc. GCVS, for example, there are vendor products like IBM Garbage Collection, GC Analyzer, and all those things are available. Then when you launch your JVM, there is a parameter verbose GC which you can set, and it will also generate very useful logs, garbage collection related logs, where allocation failures are happening and all those things. And you can use tools like GCViewer, IBM GCViewer, etc. to monitor those verbose GC logs also. There are other platforms, for example .NET, etc., which uses Windows performance counters, or there is a tool called Purview, but we will not go into detail. But if you are running on those platforms, your application is not Java, then you can use those tools also. So now we'll go and have a demo of Java GC monitoring. So I'll show you the application. We are going to simulate couple of tools, couple of scenarios. So in the first scenario, what we are doing is we are launching an application, and it is simply adding new objects in the map infinitely. So what will happen finally is your JVM will run out of heap, because we are not freeing it anywhere. Once application enters in this infinite loop, your objects will start getting allocated, and finally the heap will be exhausted, because it's an infinite loop. There is no object release which is happening. So finally your JVM will be out of memory. So we are going to run this now, and then we will see the what we will do, we'll also launch JVisualVM, which comes with your JDK. Once you have installed JDK, in the bin there is a tool called JVisualVM. We will use this tool to monitor the GC. Let this tool get started. So okay, so before you can use your JVisualVM for GC analysis, you have to add a plugin which comes automatically built in within the Visual VM, but you have to install it for the first time. In the in the tools, go to the plugins. In the available plugins, you will see right now it is installed, but because otherwise you will see here garbage collection tool. Okay, let's see if something is available or install. Yeah, so as I said, there is a Visual GC. Right now it is installed on my machine, but once if it's not installed, you can go to the available plugin, select that and do the install thing. So right now it is installed, so we'll not go in detail. It will not take more than 1 or 2 minutes, so it's very simple to install. So now what we'll launch our application. So application is gc demo.java. So this is launched. So now you will see this application appearing here automatically in the JVisualVM. So we are connecting to that, and Visual GC. Okay, so now you see this is your metadata. This is old, Eden, survivor space S0 and S1. So it will tell you all the information, like when this, now you can see old thing getting exhausted and garbage collection happening, right? 18, 19, and finally it will go out of memory. There are continuously GC happening now because your GC is under old thing is under pressure. Eden is full, S0 is full, and finally there are GC time which is increasing, right? Number of times GC is being executed, it is increasing because it is not finding the enough space. So it will keep running GCs until your total heap is exhausted. Okay, so now if you look at your application, you see out of memory, right? And your JVM is dead now. So you saw, right, that whenever initially your old was also free, Eden is also free, S0 S1 was also free, but as you keep allocating more and more objects, and you were not freeing the older object, so slowly what started happening, your object started moving from Eden to S0, and after S0 or S1 it started moving to old, and over time even old started getting exhausted because you were not freeing it anywhere, and finally your old also ran out of memory and your application failed with out of memory. So this is how it works. What we will do, we'll run it again just to make it more clear. So I'm launching it again, and now we'll connect to this application again, and you keep an eye on this. Right now everything is free. Your GCs are number of times GC happened is low, and once it starts getting filled up, you will see S0 S1 getting alternate in use, and now it will start increasing. Eden is increasing, S0 S1 old is increasing, GC happens, Eden goes down, uh, S0 and old it will never come back because we are not releasing. Now you will see this GC starting increasing, number of times collections is happening, it is increasing, and finally it will fail, but it is not able to release anything. You see everything is full, Eden is full, S0 is full, because we are not releasing this thing. Keep an eye of this. So your Eden is also full, 68 is being used, 68 MBs. Your survivor is also full, S0, and your old is also almost getting exhausted now. It will also tell how much time it is taking for these many executions of GC. So 26 collection is taking 45 seconds. So you see, as more GCs will start happening, your application response time will go down because GC itself will start taking more time, right? Because we have not released memory anywhere. So you will see finally your application getting out of memory. So now you are getting out of memory. So this is how it works. You allocate object here in hidden area, then over time whatever survives the GC, it will move to S0 or S1, and then finally it will go to the old. And if we are not going to release, then even old will start getting, you know, it will getting filled up, and finally you will get out of memory. So now we will run another scenario just to give you more idea how it works. What we are going to do is we will add enough, not infinitely, but we'll add large number of objects in the heap, and finally we'll force a garbage collection. It is not needed, but you can always force in Java. It is not guarantee that JVM will run the GC, but it will get a hint that you need JVM needs to run a garbage collection. And then we'll make it sleep for some time, the thread, so that in the tool we can see exactly how our JVM is coming down, heap is coming down. If we don't make it sleep, it will be very difficult to show it in the real life, in real time. So we'll just launch this. So application wise it is doing nothing, but adding large number of objects in the memory so that your heap is under pressure. Then we'll force garbage collection, and then we'll see how it makes, once we have forced and GC executed, use the heap which we have allocated here, it will come down. So I'm going to just let me close this thing. Now I'm going to launch this application. It is appearing. So now we have started adding it, so you will see getting hidden and other things getting increased. Now right now if you see, GC collections are low because everything is free. Keep an eye on this. Now your old is also start getting filled. GC counters increased, GC time increased, collection increased, right? Because hidden is also full, sleep, or old is also getting a bit out of loop. So now we'll make after 20 seconds we'll force GC, and then you will see right now 18 collection has been done, old is almost full. Yeah, so now GC has been invoked, GC done, and now it is in the wait, and you see everything is freed because we haven't forced. Even if we haven't forced the GC, JVM finally would have kicked it itself, but because our application is not real life application per se, so we will not be able to see it. So I've just made a scenario where I can show you how GC can reclaim the objects which are no longer in use. So that's what happened here. In first scenario we were not freeing anytime anywhere, so even if GC happened, it was not able to reclaim the memory. But here we freed that, we came out the loop, this map got unreferenced, and then when we forced the GC, it was able to GC was able to reclaim that space. So your old and hidden everything went down, and your application successfully completed. So that's how you can do the analysis of your garbage collection, how many collections is happening, what is the time being taken, whether it's the old heap or hidden heap or survivor heaps which needs tuning. You can go and tune individual heap. You can see survivor ratios and all those things. You can tune that. Just have a look at the JVM documentation how you can set this parameter. It is very simple. It is like setting the max heap for with java -xmx and all those things. So but it will give you very good information. Normally what happens is when we are debugging these kind of problems, generally you also have to do the heap analysis. So heap dump analysis is another process which is related to JVM heap performance tuning. We will have a look at that in some other session, but GC is also one of the important activity which you need to monitor and tune when you're doing the heap tuning of your JVM. So this was the demo I wanted to show you. I have showed you JVisualVM. You can use any GC analyzer tools. So if you have any questions, anything, just post your questions, your queries in the forum you find this presentation, and I'll get back to you as soon as possible. Okay guys, thank you very much for your time.